My name is Edgardo Menendez and I am with Group 12. We have come a long way since first presenting the robot. Some physical updates that we've made to the robot include a better looking and more capable device. We've added extra plexiglass to hold up the two DC motors to give them extra stability. We built a gate with plexiglass and a servo motor that will control the flow of the balls that go into the firing mechanism. And we've also replaced the wheels that we had because they wobble too much, and this was disrupting the trajectory of the balls. The new wheels don't wobble. We've also attached the DC motors in a way so that the vibrations are decreased for increased longevity and less maintenance of the robot. Despite all of this improvement, we still have to improve the robot in certain areas. Since the robot does still vibrate a little, we have to have something to damp out those vibrations, so we're going to add some rubber bushings in between some of the screws and the plexiglass to cancel out the vibrations. We hope that this will reduce the vibrations and hold the robot together better. We have to cover some exposed connections to decrease the possibility of a short or any other hazard or maybe a shock, and we also have to shorten and cover the wires with some flexible conduit. We have to also attach all the components like the amplifier, the power supply, and some of the wires to the base of the robot to make the robot more portable. Some of the things that we thought could cause harm to the robot, its users, or the surroundings included the DC motors, the wheels, the Lazy Susan, the servo motor, or several motors, the base corners, some of the wires, the screws, the amplifier, the power supply, the gate, and the hopper. The DC motors could fail in such a way that they could misfire and fire the balls by mistake. This would defeat the purpose of the robot, and the robot would have to be repaired. The wheels, they could fail because over time they could become loose from the motor shaft, and they may detach from the motor shaft. If the motors are running when the wheels detach, then they could potentially fly off and hit someone. The Lazy Susan, the piece that turns the robot from side to side, could also become detached over time from the plexiglass that it is holding, because the vibrations created when the DC motors run could cause the screws that are holding the Lazy Susan and the plexiglass together to vibrate out of the nuts. And since the Lazy Susan has a very sharp edges, this could be a problem because they could cut someone if enough pressure is applied to the edges. The base corners of the robot's base platform, which is made of a rectangular piece of plexiglass whose corners are very sharp, could cause a problem if someone were to run into one of the corners and hit themselves. It wouldn't cause that much damage, but it could hurt if they were to hit themselves with it, or maybe it could cause a lot of damage if a child was to be playing around that area. The wires could catch on fire in the unlikely event that a short circuit happens, or the wires are taken beyond the rated values, the rated limits. This would create problems for the operator, the robot, and the surroundings, because the wires could catch fire, potentially harming the operator and burning them, or maybe even shocking them. The robot would be destroyed if it caught on fire, of course, and the surroundings could also be destroyed. Another problem that we saw that could happen was with the screws. The screws right now have sharp tips, which will have to be changed. But if left like as they are right now, this could cause harm to someone not paying attention to the placement of the screws. But the screws will be replaced with flat-ended screws. Also, the amplifier could fail. If the amplifier were to fail, it wouldn't necessarily hurt anyone, but it could be detrimental for the robot's operation. If it were to fail, some of the motors could become damaged, or they would just stop working and the robot would become useless. or until the amplifier is replaced, of course. The power supply could also fail if the transformer inside of it caught on fire, which is something that could happen. Since the power supply was bought already built from a company, then this is not something we feel like we have to worry about too much, but it is something that could happen that needs to be looked into. The gate, although it won't never hurt anybody since it's just a small mechanism, it is very essential to the operation of the robot, and if it were to fail, the balls would not be able to be loaded into the robot correctly, and the robot will become useless until a new gate is built or that gate is fixed. So the gate's operation is very essential to the robot. The hopper's operation is also very essential to the robot because it's what's holding the balls together before they're fired. In the unlikely event that it fails, say it breaks or something, then the balls would have to be fed to the robot manually, which would defeat the purpose of the robot working by itself. Thank you for watching video update 5, and we will see you at the tournament.